Welcome everybody to the second webinar in Greywater Action 2016 series. Today's topic is Greywater Irrigation and Plant Health. Before we get started, I have a few housekeeping items to remind everybody that there is a chat box. You can type any questions or comments you have. It's on the left side of your screen, and we'll be taking some pauses in the presentation to get to your questions. And also, if you want to view the presentation in a larger screen, if you take your mouse to the upper right-hand corner, there's little arrows you can click, and that will maximize the screen. You might want to do that when you see some slides that are a little more detailed. And also to let you know that today's presentation has a lot of really great information, and because of that, we're going to just take two pauses for questions. So we're going to hold off until we get halfway through the presentation, and then we'll stop. And then we'll also stop again at the end for more questions. So I'm very happy to introduce our presenter today, Regina Hirsch. She's a very experienced Greywater installer and designer, and she's a great person to work with. I'm very happy she's with us today. Her company, Sierra Watershed Progressive, has installed a lot of different graywater systems at both the residential level and the large commercial scale projects, and she'll tell you a lot more about that today. So welcome, Regina, and thank you so much for joining us.
Thanks, Laura. Thanks for having me. And welcome, everybody. So today we're talking about plant irrigation and plant health, and really focused around graywater irrigation. And one of the slides we always like to start off with is really talking about that, you know, there's no single magic bullet that's going to solve everything. And typically we talk about this in terms of your bigger toolkit, meaning your other water reuse toolkit, like rainwater and graywater or mechanical water and stormwater. But I included this slide just because I feel like there's still that question in plants. And for plants, people are looking for the perfect plant, and they say, tell us the plants, just give us the plant list of what plants will work, and we'll plant them. And it's not just one single plant or one single plant list, and there's a lot of considerations to think about in making sure that graywater works with your plants. And in saying that, I should also say we've never seen a situation where graywater doesn't work when it's healthy graywater that's coming into your receiving basin or your soils. So it's really more about the quality of water and not so much about the actual plant you're using. And so we'll talk more about that. So today, just to go over what we're going to talk about, is mainly we're going to talk about why we're going to irrigate with graywater and with what types of plants and in what context. And we're going to talk a little bit about whether to water existing plants versus new plants, and going over different types of uses and surges to those plants. We're going to go briefly over the mulch basin and how to plant a mulch basin, a little bit on whether stormwater input can affect your mulch basin, lightly touch on plant health and drip irrigation, and the safety factors therein. And Laura's asked us to go over a case study of Evergreen Lodge, which is up near Yosemite, and the monitoring program. And from that, we've learned a lot of lessons, and we have some successes, too, we want to talk and share about, and then we'll take even more questions if we have time. So just to introduce ourselves as Sierra Watershed Progressive, we do travel throughout Central California, and we're focusing on demonstrative and residential, but more high demonstrative graywater, rainwater, and different alternative water conservation projects. And in those, we've been monitoring. And so we've been taking measurements and baseline data as we go and trying to come up with the best toolkit and approach for each of those. And we can always we'll share a little bit of that information. And so moving into why use graywater, we all know we're in a drought, and we all know that our groundwater depletions are going down quickly. And this is a graph from the GRACE satellite and USGS's data of the San Joaquin Valley. And here we have an overall trend, and you can see there's spikes in this graph where perhaps we had some El Nino years, and those wet years are even highlighted. But overall, that trend is going down. And in drought years, of course, we use and pump more water, knowing that a lot of our water goes to agriculture, but also in the residential and commercial setting, usually more than 50% goes to outside irrigation. So graywater is a fantastic solution to really help alleviate the stress of a drought. And then this next chart is really interesting. This is from the NOAA's National Climate Data Center. And this is looking at, you can see the dates are a little small, but from the end of our last century, comparing the water stress in plants. And the top section is really what the water stress index was in plants until 2000, I believe in 2007. And then the bottom chart is showing the percent change that they are expecting by the middle of next century. And you can see that the West compared to the East, the Western United States, is expected to have really catastrophic change in the water stress in plants. And so going back to why we should use graywater for irrigation and our plant health, we can use our wastewater on site to really help alleviate some of the stress in these trees, like what we're seeing in our bug kills in some of the forests and other places, and really help create a more vibrant ecology around us. Some other reasons graywater is so fantastic for irrigation. Of course, it creates a more connected water user. People tend to really care about what they input into their water and how much water they use. It does decrease potable water demands, of course. And then we create robust plant health, which is really what we're here to talk about today. Taking these three thoughts a little bit further, it can create a really community benefits, and we're not going to go into all these around the circle, but just to keep in mind there's all these other added values that we have yet to ask questions of, find out the answers, and see really how we can increase the value of graywater in our irrigation and what it can do for our economy, our social fabric of our communities, as well as our watersheds. Moving into what to irrigate. We have new plantings sometimes, and then we have existing plantings when you go to a client. And it's hard to decide, should you put in the new plantings or should you just irrigate the existing plantings? And there's pros and cons to each, which you can read here. We're just going to go over quickly. The pros of the new plantings, they can develop the root systems easier. And so we've seen this over and over. If you plant a new tree, those trees really become accustomed to where the water is. They actually have little noses for water and nutrients on their root tips, and they can smell and detect where water and nutrients are. So they can create their root system perfectly to where that graywater surge is and be accustomed to that pattern. And you can also make better decisions in that landscape. You can say, I'm going to add an additional shade tree or an additional fruit tree because I now have this extra water, which, of course, the con to that is it doesn't decrease your water budget. So if your objective is to decrease the water budget, you may want to water your existing plantings, which really will save you the water, especially if you can focus on one entire zone of irrigation. And so if you can get all the trees on one zone and you can then turn that zone of irrigation off, then you can really see the water savings. Additionally, on the existing plantings, we usually increase plant productivity rates, which we've seen and we do measure, and we'll talk about that a little bit later. And we haven't really seen any cons to giving graywater to existing plantings, except for in 2 to 3 cases where we've seen a little bit of pruning to some sensitive roots where they didn't like the surge patterns, but they did recover. And it just takes a little bit longer for those trees to readjust. So this is just a decision, not a decision tree, but essentially some helpful thoughts on what the appropriate choice or thoughts could be when you go to decide what to irrigate. And the idea is for us to get as many different multi-factors as possible. So just going around the circle here, we can see shade trees would give us a lot of energy as far as shading a house on the southwestern side. They're faster growing, and so we get a quicker return of investment. So giving that water to a shade tree sometimes will increase the land value quicker. It'll give us that energy savings, and of course it adds carbon and habitat to the property. Whereas fruit trees will give us food security, and it really gives sometimes a localized economy if you produce quite a few fruit trees with your graywater. It can be a really beneficial insectary, meaning it gives a habitat to the important insects that create pollinators for your neighborhood plants. And there's a lot of different uses for hardwood of fruit trees. You can reduce zones of irrigation, which will save you water, which we talked about, and it'll also save you energy savings by reducing your zones of irrigation from reduced pumping. Sometimes you want to just supplement irrigate with your graywater because maybe it's a vacation home or a different kind of pattern. That is sometimes still worth it because it can increase your growth rates, it will increase fruit production, and it will increase that soil regeneration, which is so important for the health of our plants. And this slide is really just to take it home that there are multi-functions that these plants are giving us. Plants can buffer toxins and perhaps even the emerging contaminants that are in our wastewater. The soil will build and help with that toxin buffering. Human use, we have foods and medical uses of different plants that we can put into our surrounding landscapes. We can create wildlife habitat, which is really important. And something we always forget about is really the habitat for ourselves, that human habitat, which is so important. And then something we're going to talk about in a few minutes is really the climate factors. Plants put in the right position can reduce our energy bills and regulate climate, but perhaps they can also regulate some catastrophic events. So talking about these catastrophic events here is we have a wild and urban interface, and here we're going to go over a couple slides that have some plant lists. And I want to just say a few notes about these plant lists. These are lists of plants just as an example. There are a myriad of choices. You can use almost any plant you want as long as you put it in the right position. So these are plants that I picked out because they're either, number one, my favorites, and we've seen them respond to graywater really well in these conditions, and I think they can be used statewide. There's a caveat on this list, quaking aspen, which can be planted statewide, but it's not very well lived. It doesn't live more than about 10 to 15 years in the San Joaquin Valley or at the coast. So that's probably a plant those of you in a lot of California don't want to use, but we've had a lot of success with it. So the wild and urban interface is an interesting thought process that's happening. Is a lot of California's population centers are moving out into these zones of a natural existing corridor where we're interacting with this wildland interface. And what happens there is these catastrophic fires like we saw this last year with the Butte fire and other fires. And so what we're hoping is maybe these wastewater remnants, instead of pumping our wastewater off-site and sending it to somewhere that has to process it, is using it on-site with the right selection of plants that are retardant or resistant to fire. And we're going to talk about what we've seen with this effect later on when we talk about Evergreen Lodge as an example. But I want to just start the thought process rolling that there are plants that are not fire-prone and that are fire-resistant, and that we can use those in our landscapes with graywater irrigation. So the next group of plants that I want to talk about are the California processing plants. And they like really variable saturated soils. And there's a whole host selection of these. And there's a fun rhyme, if any of you have taken a botany class, that sedges have edges, rushes are round, and grasses have joints all the way to the ground. And sedges and rushes especially are extremely robust California natives that can process toxins, nutrient loads, and really deal with a large array of wet to dry factors, heavy to clay soils, deal with open pore spaces, as well as lots of pH ranges. And so they are just the wonder world of doing these low-impact development treatments and BMPs on our properties. Grasses are really interesting that they have such a fibrous, high surface area root mass that can really take up a lot of nutrients as well. They need a little bit more porosity, and they don't want to be as saturated as a sedge or a rush. All of these can dry out, especially if you use the California native varieties. Some of these are listed here. Not all of these on this list are the sedges or grasses or rushes. There's a few others like the red dogwood, and there's big leaf maple and others that you can look at. When do you use these? With a client that's using graywater that's dispersing, maybe has a lot of large events, which we call hurricane events. When there's an area that you have maybe a lot of bathtub surges, clay-based soils, or when you don't have enough footprint really and you have to put in a small basin. So you know you're going to perhaps have a high likelihood of saturated soils. Perhaps you have a stormwater run-on area that you might have a little bit more saturated soils from stormwater, or an area where you think your inputs might have a little fog in them, which is fats and oil and grease, which is typically associated with kitchen, which is not legal in the state of California quite at this point. So the next list is ground protectors or ground covers. I call them ground protectors because they really do help stabilize that soil on the surface, and they cool the soil, and they provide a never-ending host of features. They have animal habitat properties. They can cool the companion they're planted with, like a neighboring tree. And a lot of landscapers don't like to plant them because they feel like they will be running throughout the yard. However, you can really control them if you use the right plant by just how you put the dispersal of the graywater. And here's a picture of heuchera, or it's also known as alum root, alongside a building that's watered with graywater. Here's the probably, I feel like, the most under or missed group of plants in graywater, which is the upland or top terrace plantings. And these are usually shrubs, sometimes perennials, that can still be planted alongside with companion planting of graywater trees or main shrubs. And here you can see the little diagram picture of the human on next to the tree where it says upland. These are planted in an area that most likely will not get much of the graywater. It might just get ancillary graywater or start to pick up on the moisture in the soil from the soil that is growing and being more robust because of the graywater being dispersed to its neighbor. Most of these plants can take graywater, but they can also dry all the way out. So they're really got a high range of variability of wetness and dryness, as well as different pH ranges. They are fabulous for providing habitat for pollinators. They build guilds, which means they help assist other plants to live and grow, get nutrients and other minerals. Again, animal habitat, and they cool the soil and really help reduce maintenance by not having as many weeds. And they are the signal plants for creating a true habitat that works as a plant community. So these plants, when an animal or a browser or a virus or a different type of insect comes in that is a problem, it will actually signal to other plants outside of its species to alarm and have the other plants beef up their defenses. So these are a really important part of a plant community and a successful landscape. Lastly, these are medicinal plants. They're plants that, this is where we find the majority of our medicinal plants, is these type of plants. And again, these lists are not comprehensive at all. These are just a few examples of some of the things that you can plant. So moving into just how you would want to make the decisions on how to irrigate these plants. And this is a picture of my son with the Emergency Drought Response Program crew that was up working at Evergreen Lodge. And here they had come up with their own branch chain designs for their own houses. First of all, you need to know how much water you're dealing with. And this occurs a couple ways. Number one, we all know we need to talk to the clients and know what the real usage is in their home. This has to be demystified by them actually realizing how much water they're using, and it's a fun experience for them to fill out a survey and try to actually track how much water they're using. That's one component. The second is to actually see what their appliances and the pressure of their system that they're using. We used to go by a lot of the manuals for a lot of appliances, especially laundry machines, until we started to run into some problems where we were getting some plant health problems. And one of them was from a laundry machine that was rated as a low water use machine, and it was rated around 11 to 17 gallons per load, and yet we couldn't get our system to disperse all the way to the end, and it ends up that it was using between 3 and 5 gallons per load when we actually tested it. Excuse me. So from that, we started testing the laundry machines before we actually went to use them, regardless of what the manual said. And here is a picture again of the Emergency Drought Program crew down in Southern California testing a laundry machine. These laundry machines were at a dorm school, a resident high school, where those machines were rated at 27 gallons per load. And so we came up with what we expected that wastewater to be generated from each of the dorms, and you can see that chart there. Now, if you look at this picture, there's two 35-gallon trash cans. And if you can see a little bit closer, which the picture's not so great, you can tell that they're both almost full. Those are all from one machine, and it ends up the machines, under all conditions, were still putting out 58 gallons per load. So we were having a water problem on the other side of the spectrum where we were getting a lot more per load. And what that looks like in cumulative for this school was a lot more water. So you can see per week we were looking at, instead of 12,000 gallons, we were looking at 27,000 gallons. And that can really affect your plant choice, your plant health, and really how you zone out and deal with your water. It's a very large difference, especially in cumulative. So once you know how much water you have, you also want to calculate how much water your plants need. It's a very simplistic equation, and from this you really need to gestalt a few things. Sometimes you live in an urban area and you have a lot of data on what your plant needs are, how many inches per week those plant needs. And you use a real basic equation like this one, and they're all over online if you need a calculator. And essentially you take the canopy of your plant and you take the coefficient and times it, or the conversion factor, and times it by the inches per week. And where you get the inches per week, really, there's a lot online that you can look up, and there's different ways to come about it. Laura actually told me about WaterWonk, which I really like the website. It's really easy to use, and there's a nice app. Again, it is mainly for more populated areas, but even I could find my zone on WaterWonk, and I could look up big leaf maple and look at different types of soil types and different types of gallons per hour drip recommendations, and you can see that here. And so I urge you to go online and you can look at WaterWonk, or there's other tools to find out really some sort of estimate on what that plant needs. I just want to make a little caveat that if you're planting that plant and it has a high variability of sun versus shade requirements, just make sure to go over your math. If you're planting something that requires some sun and you're planting it in shade, And even though it can live in shade, you're going to use a lot less water versus a plant on the other side of the spectrum. You'd want to go ahead and use more water and give more water to a plant that's in full sun in a hotter climate on perhaps the apex of a hill that's going to be windier and have more evaporative stress. So again, just to make sure you're still looking at your site, you're not just looking at a computer at the ET values, that you want to make sure that you're looking at where you're placing the actual plant and making some fine adjustments for that plant. And then you want to think about how you're going to disperse that to the plant. Most plants can take any kind of dispersal as long as you put the dispersal in the right place for the right plant. And the two different types of dispersal in graywater are a surge type, and that's mainly a gravity flow, and that's coming from an ABS pipe from a shower, a typical shower, or sometimes a sink installation. And it's coming out either all at once from a bathtub or a shower, or it can come in short surges that are pumped under pressure from a laundry to landscape system. There's also drip irrigation or sometimes a pump effluent system where you can control the dispersal a little bit more. And so you want to make that decision on how you disperse it. And I'd say overall the best system really is the gravity system, and the branch drain system is the one that has the least amount of maintenance. You just want to make sure that plant is positioned in the right proximity to the dispersal for what type of soil and wetness it likes. If you're dealing with an existing plant, you want to put the dispersal spot for that plant. If you're dealing with planting a new plant, you want to place the plant in the right proximity to that dispersal. Here is the receiving basin for a surge dispersal, and we call it a mulch basin. And you can use a mulch basin even if you don't have a surge capacity. So if you are using a pump-controlled system, there's no reason you can still use a mulch basin to receive any kind of drip emitter. Most people don't use this with drip irrigation. This is usually just primarily used for a laundry to landscape system or a branch drain that comes from a shower or a sink. And so the water flows into the system, and this whole trench is filled with mulch. And if you want to learn more about this, if you haven't seen any of the Greywater Action webinars before, there's laundry to landscape and branch drain webinars, I believe, online that you can learn more about it. This is a cross-section, just a typical cross-section. This would be for a laundry to landscape mulch basin, where you can see the 1-inch to coming in and arriving into that mulch guard or valve box 2 inches below the surface, and it discharges onto the mulch basin, which is full of mulch. That mulch provides the filter of all the water and the surge capacity in case there's a larger event. So moving just into drip irrigation and that type, what we found is we use a mulch pocket, and so far that's the term we use for it, and really it's just a miniature mulch basin. We take our irrigation emitters and we put it into a 4-inch pipe, which acts as a mulch guard, just like a 7-inch round valve box, but yet we use a 4-inch pipe. We protect that mulch that emitter with a 4-inch pipe. We put mulch all the way around and underneath, just as in the mulch basin, and that gives us a larger range of dispersal and a deeper root zone. We think that it also gives us a little bit more filtering power for dealing with uncertain water quality that may or may not come through into that water, even though the water is a little bit more either filtered because it's passed through a filter to go through irrigation line or a drip line, but we still, as far as pHs, that mulch factor can really help buffer that. And so we've found this to be really effective. The difference is a lot of other groups will use drip irrigation line, and it really kind of just sits on the surface. And we've done that a couple times, and it seems to just kind of run off just like normal drip irrigation. we found this so effective that we're using this in our drip irrigation that we use for potable water as well when possible. And so this is just another earthwork. It's a little bit more work. You spend maybe 12 inches down and 12 inches over to provide this mulch pocket, but it's highly effective. Another consideration is that it rains on your mulch basin or your earthwork. And so making sure that you are looking at where your runoff is coming. And so you can see this in this graphic. This is the blue arrows is the rain. It's kind of the slope where the rain is running into the earthwork. This is a swale. Now this can be a mulch basin. It could be a stormwater bioswale and any kind of earthwork. But we want to try to not mix stormwater and gray water to the point where it would ever pool and run off. So we want to look at what is coming above our mulch basin. Do we want to use that water or do we want to route it around? And there's a lot of instances where we have put mulch basins right next to a rain downspout, and we want to make sure not to include that rain downspout right into our mulch basin, or if we do, we better go ahead and turn that into a stormwater basin and use our graywater irrigation only in the summer. An important consideration. An example of this is at the National Guard, where we did a stormwater graywater project / rainwater project. And this is a funny-looking earthwork on the left that had different terraces, and these are about 3.5 feet deep. And so the storm water, they were having flooding problems, so we captured the storm water that was creating nuisance flooding, and we would put it into this earthwork. These on the picture on the right are 2 dorms with shower banks, and you can see the windows of the showers. And we took the shower water of the gray water and used that for irrigation during the summertime. And so we took that gray water and put it into this earthwork to irrigate those plants during the non-stormwater times. And so this was really effective. I also want you to note that if you look closely at the photo, you can see there's even rainwater catchment, and there's rain downspouts that are plumbed into the rain gardens on each side of the pathway. There's also those top terrace-type fill-in plants that are throughout the buildings that are getting just ancillary benefits, but they are growing better because they are put in next to an earthwork or in an earthwork that's watered with gray water. I should also note on that previous slide, this picture on the right was right after this installment was right at the beginning of the drought, and the first year we got only 8 inches, so we thought nothing would grow. And so you can see these plants were not even a gallon in size when they were put in, and you can see the plant growth all within 1 year during a drought. Plan basics. Just going through this quickly, typically the things that are required by a plan will also be the things that will help your plant health. So know your soils, know your percolation. Certain plants need to have the right soils and percolation. Estimated water gallons per day and per week can really help you understand what plants are best suited for that site and that flow pattern. If you're using a flow pattern that's mainly a hurricane-based event, you want to use those plants that are in that saturated soils list and really research those. Making sure to see what those user patterns are very important to success, and we're going to talk about those in just a minute. And just in the interest of time, I'm going to move through these pretty quickly. This is a branch drain diagram. Again, we're not here to learn branch drain, but here's 10 gallons going to a tree and 2 shrubs, and just to note that you can plant them in various ways. Typically, people put a plant right in the middle of that mulch basin. Please feel free to, if the tree needs a little bit more water, put it on the side instead of right in the middle. Let it get a little bit more water, and please put 2 outlets for each tree to give a better root base, a stronger tree. It anchors it to the soil, keeps them from falling over in high wind events, and it creates better, easier maintenance for you. safety factors, just a touch on safety factors. The number one safety factor here is really to use mulch, which we're going to go over. Use the right plant choice. There is so many different myriad of different plant choices, and to talk to the right landscaper, or really just to go around that neighborhood and find what's working for that soil. Again, there's no mystery to, you can grow avocados with graywater. It's really what's in the graywater and managing the inputs. And so managing those inputs is the most important safety factor. Here's a hand sink water notice we did for the Mono Lake Committee. And really this is our number one route to regulating inputs, is really just making sure people understand that the water that goes down that sink goes to the trees, and we haven't had any problems as long as we have the right kinds of considerational signs. This is a schematic sign, really to talk about using the right plant choice again. Sometimes you have a large amount of water in a hurricane event. Sometimes you have a large variable pH. Selecting a plant that has wide ranges that can either be drought tolerant or uptake a lot of water is a fantastic safety factor. And sycamores themselves grow in areas that can take flood or famine as far as water, and also in different variable climates. And so looking for those plants, if you're adding new plantings, is really important. This slide is really to talk about using different types of surges in respect to planning. And this is a family residence where we have a master bedroom on the left that is going to continually be used even if the house is sold. There's a kids' bathroom or guest bathroom in the middle that has 3 children in the house now. And then there's a laundry to landscape system on the right. And so really thinking about the considerations that those children are going to grow up, move on, and probably be not in the house, and that bathroom won't be used as much. It's important to say, okay, what's going to happen to this house if it's sold or once the children are gone? We want resilient systems. And so taking the master bedroom and using trees that need a little bit more water for fruiting and shade, and keeping the southwestern side of the house nice and cool is a good decision. Using plants that can get off water and just take occasional amounts of water, but using the children occupied in the bathroom right there to get the plants situated and acclimatized while the children are using the bathroom. Once they move out of the house, those plants will be established and a little bit more drought tolerant, and the same thing for the laundry to landscape. And so again, just thinking about what is the future user and what is that surge pattern. Again, we talked about signage, making sure you're tying those signs back into the plants. Most people will not care if they're putting poison into their soil, but they will really care if they're putting poison or something that will really cause the plant health problems. And there's a list of different detergents that work there on the bottom right, and I think there's even some more on the Greywater Action website. So our common irrigation pitfalls, just to sum up before we move to Evergreen, is really the user-dependent, that this is a manufactured substance, and looking at those flow patterns and how the user is going to interact with it. Anytime we store graywater, we're presented with maintenance problems. Anytime we filtrate it, we're having a really weak link that could cause problems. Sometimes we've seen improper mulch basin sizing, and that the mulch basin is either too small to really handle that surge capacity, especially for the soils, which leads us, of course, to improper soil analysis. Improper plant choice is typically more about where you're placing the plant and where in proximity to the dispersal, or that you're not putting the right plant in the right place for the right sun aspect or wind aspect anyway. People ask all the time, do I design the mulch basin and the sizing for the immature new plant that I'm planting or for mature sizes? You want to go ahead and plant it for the mature plant. It doesn't mean that you put your dispersal far away from the plant. You may have to change that over time. We have not seen that we've needed to change it at all. It was one of my major concerns when we started. The plants tend to really grow around and get used to where that water source is coming from. And lastly, making sure that we're looking at how much energy we're spending in our systems and using the most appropriate tool. Not using a pump filter system and drip when we can just use a branch drain. So the importance of mulch. We can't talk about plant health without just going over the topic of mulch for a few minutes. And mulch is really, what is it? It's either the woody mulch, like in that last slide, or it's the leaf debris that's all through the forest. And so letting the leaves and the plant detritus fall onto your mulch basin is a really important part of plant health. The plant immunity that grows all over the leaves and the leaflets that fall onto the forest floor or onto your landscape floor is self-selected immunity that's already all over the leaves from that tree. And so that tree can really, that leaf can really inoculate your mulch basin with the right kind of bacteria and fungus that helps provide resistance from infection of other diseases and then against drought. The mulch provides a safety factor. It's a filter medium and actually does filter the water. It balances the soil moisture by panning it out and the pH. It provides nooks and crannies for all the micro and macro diversity, and it really improves the soil condition by deflocculating clays and opening up the percolation depth. It reduces reliance on a maintenance level for synthetic filters. Sometimes people put in gravel instead of mulch, and the maintenance is really terrible compared to really just letting the mulch break down into compost. And then also that added carbon from the mulch denitrifies the wastewater. And there's our usable products. So this is once the mulch basin really breaks down. The other last added part of mulch that we're finding is when you have to take a jackhammer and work in these really tough clay soils to create a mulch basin, by adding mulch into these mulch basins, we've been finding by using a compaction rod, we've been measuring the amount of pounds per inch that we can push down into these prior to putting the mulch in, and then every about 6 months after, and seeing what the difference is in soil compaction. And throughout Central California, we're finding this very interesting. And again, I should say this is just trendline data. This has not been statistically analyzed, but we're finding this really interesting trend lines that through these clay soils, we're finding almost every 6 months that these soils are opening up. Now, are they percolating more water? We don't know. We haven't done percolation tests. All we've used is the compaction rod testing. You can see, and for some reason, the x-axis is months, which, it is showing up here, and the y-axis is depth. And the line that is light blue moving to the top of the corner to the right is Evergreen Lodge, which we actually, to be fair, is past that in measurement. We haven't been able to find a way to measure past that. So we're getting into feet of soils that are decompacted in these mulch basins with a control on the outside that is still really compacted. So something in these mulch basins is really allowing for this decompaction. And why does this matter, and why are we excited about it? Well, as we find places that we need to put our wastewater on site and different reasons why we want to put graywater on site, whether it's for irrigation or stormwater or black water, it's nice to know that we can open up these types of soils that are clay soils in California, and that these soils can turn into a habitat regeneration by adding different types of plants that can add to the soils. Those soils will improve in structure and thereby allowing for more wastewater inputs and processing. That's a really important key to perhaps dealing with some of our contaminants of emerging concern and other toxic problems that we have in our wastewater systems. So with the 15 minutes I have left, we're going to go through Evergreen Lodge, and I'll try to go through this quickly. And those of you who have been there know it's right outside of Evergreen Lodge. Outside of Yosemite National Park. And it essentially has about almost 2 million gallons a year of graywater reuse. It's on 20 acres, and it was installed about 6 to 7 years ago. It's got quite a few different treatments. And a basic note on this is we were going to do a centralized system on this until we took a few extra classes, including Greywater Action, and saw some examples that we shouldn't really need to move and pump the water all over to one distinct centralized location and just pump it back when it really needed to go just right outside the door. And so we decided to keep all the graywater local. And this is what it looks like. This is just the kind of the zones on a real gross scale of where the graywater was put. And I should note 2/3 of all the irrigation there is graywater. It's still not, we still do have some potable water systems. And about 78% of all the graywater is irrigated for existing plantings. So there were some plantings we added just because we put graywater in. We didn't use it on the lawn or on the outdoor dining or children area. To go over just some of the categories of what we did here, we took the staff dorm showers and laundries, and we put it through a pump filter system and laundry to landscape system that goes through the plaza and outside the front of the lodge. We took the manager dorm shower and blended it, just mainly for blending to buffer the commercial laundry system, and that goes around some cabins, but as well as up to a different hardwood forest, and we have fields of rest in case there's saltification or any other problems, which we haven't seen yet. We have 52 guest cabins that are mainly all showers. They're almost all branch drain systems, and this is the best case scenario here as far as maintenance and actual plant productivity. We've had the best case scenario in every measure with the branch drain dispersal. These cabins are duplex cabins, and so here's a layout where there's 2 cabins, essentially a duplex. And so we just very simplistically, just like you would in a resident, use a diverter valve underneath the cabin, and we put it out to the surrounding landscape. So there's no pumping. And again, if you're not familiar with branch drain systems, please look them up on the Greywater Action webinar. And again, we kept it decentralized. We kept it local. And we used the cases of planting the plants where we needed either privacy, screening, or some other reason that we needed a plant there, and we only planted the plant really if we needed it there. In some instances, we did have to pump, and there were a few pump cases, which are on the left. You can see the squiggly line kind of moving through on S4 and S3. On S4, there's a pump system, but in most cases, we used really simplistic branch drain systems. And so when in doubt, keeping it simple worked best. And this is what some of the branch drain systems results look like. The pool showers were not at 365 days a year, but the pool is very popular. And here we had a problem where they wanted to not put a covered roof over the shower, and they wanted to capture the gray water. So we just came up with a real simple slab that was sloped down, and we captured the gray water directly into a trench, and it went under a little riser gap. And that trench, because it was a little bit of a saltified water from the saltwater pool, we planted it with saltwater plants, and we had overflow ABS pipes to go to a branch drain system. And that's been really popular for viewing, but it's also the plants have done really well, and it's a simplistic system that's working. Our safety factors here that have been popular is really we have the maintenance contract. I highly recommend having a maintenance contract. You can keep tabs on the system. We just layered in hand sinks as we went. We weren't sure what the transient occupational guests were going to put down their hand sink, but after looking at the gray water coming from the cabins, it's been very benign. And so we are now starting to layer in the hand sinks. We haven't put any dispersal into the children areas at all. Our lessons learned, and just to highlight a few, mainly staff management. That has been our hardest lesson that we've learned, is really to change the culture into a culture of where the Evergreen staff understand gray water, the laundry facilities managers understand how to use and not resort back to bleach when they get scared about the ineffective agents, and finding the right agents, which we finally have dialed in, and also just to really understand and get the right signage down in the cabins so we're really effective on regulating the inputs. We have a monitoring program, which we do essentially annually. There's some things we do quarterly. The one thing that's not listed here is macroinvertebrate biodiversity, which we only have done 3 times. It's very expensive. And so all of this we put into a monitoring report annually. And so far we've actually been surprised to see that we've had really no caustic agents. The soil conductivity has remained really stable, so there's been no saltification that we've seen. Again, we talked about the compaction rates. Another surprising trend is we didn't know if gray water was actually going to be used by the plants or just disposed of in the mulch basins and used by the soil. And here is a chart, just a trend chart of occupancy rates turned into gallons per day with the different tree productivity index. And that index is essentially a measure of biomass or plant productivity. And this shows the cabins that are used and occupied more often correspond to the plant growth that is surrounding them. And if you take a walk through Evergreen Lodge, you can see the cabins that are near the pool, they're occupied all the time, have tremendous plant growth. And the ones that are on the corner that aren't as nice or as desired have pretty stunted plant growth. And so that's just all this is saying. And last, sometimes there's disaster effects and there are fires. And so Evergreen Lodge was in the middle of the rim fire. It actually came onto its property and burnt all the way onto the property. And I should note, let me back up there. The rim fire came in during the drought, stressful drought year, very hot summer, and it started in August. The lodge was evacuated. No gray water was being generated whatsoever. And there was also no potable water irrigation being used because all the water was being used and pumped to fight the fire. The lodge was evacuated and nothing was irrigated, and we got into the lodge in November 3 months later, and we were sent in to essentially assess and see how much plant damage had happened. And we had pretty much expected everything to be dead. And this is what we found is, again, the graywater plants is about 2/3 of the population of all the plants, and we hardly saw any mortality in the graywater irrigated plants. Almost all of the potably or irrigated plants had perished, not all, but a lot of them, the majority of them, and it was extremely surprising. And so this is our simple plant count and percentage. And you can note here the plants of graywater that did perish a little bit more happen to be in the plaza, which are on drip irrigation and didn't have as large of a mulch basin. So people ask us all the time if this is a function of the mulch basin. I would assume it is, but we need more monitoring and a little bit more data to say for sure. But it's a really interesting wild and urban interface observation. Our successes here is really that branch drain system. We've had a lot of high mulch integrity. We haven't had to do a lot of maintenance with a mulch basin. We've had the county and the landowner buy-in. We went from a county, this was their first graywater project at all, and they had never permitted a graywater project before, and the landowner was a little worried about doing graywater, to now they're doing a second lodge right down the road outside the gates of Yosemite, where they're going to be doing 95% capture of graywater. So it's really turned the tide in our county, in our area, taught us a lot about different systems, and it's alleviated the stress on their septic system and their well. We've had quite a few conferences up at Evergreen Lodge. As you can see here, we'll be having another one the first week of November, if you're interested. And then our need of improvements in closing is we've pretty much improved everything we think we need to, except we still need more funds for monitoring. And with the last 4 minutes, I think we can take some questions.
Yes, if anybody has questions for Regina, feel free to type them in now. It doesn't look like we have any questions. I know that was a lot of really great info, and maybe you need to digest it a little bit. You will all get the recording, so you can go back and rewatch it. Okay, now some questions are coming in. So does any kind of mulch work, Regina?
That's an interesting question. I would say diversity is the key, and so if you can have a larger chip of mulch would work, and you don't want to use a diseased tree mulch on the same type of tree. So if you're, for example, putting one type of tree mulch onto another, I would try to use something that's diverse and mixed. If you can get a larger size, you're going to really reduce the breakdown time. So we try to use about 3/4 inch to 1 inch if possible, but we also just use it from the local tree shredders and chippers.
So now there's a question about stormwater management. So with stormwater management, it's requiring you capture and reuse the systems. Have you been able to offset stormwater requirements by using graywater?
I have not, but that's an interesting question. I don't think that you would be able to really offset the stormwater requirements by using graywater, but what you could do is probably build a more robust plant system that would uptake more stormwater by irrigating it in the off stormwater season with graywater. So if you irrigated that stormwater basin or swale with graywater, you're going to create a larger root zone and mass that would really uptake a lot more stormwater and filter a lot more stormwater during the winter. So I have not been able to offset that yet.
And I do want to note, for people who were on the webinar that we had about branch drain systems and also arid climate irrigation, the presenter was from Joshua Tree, where it's very arid, gravel, sand type soils, totally different context than really hard, heavy clay soils, and he intentionally would direct the rainwater into these really large graywater basins. So we didn't really have a chance to talk about the differences in climate and when you'd want to direct rainwater in and when you would not want to, which you talked a lot about, Regina, with the clay soils and infiltration issues.
Right. Right, and stormwater and graywater earthworks can be very similar, and so I really hope that people look at what their stormwater management is while they're building their graywater earthwork, and make sure they account for that with their soil type.
Yeah. Okay, so we're at the end of our time. Thank you very much, Regina. And thanks everyone for joining us. And just a reminder, I will be sending out the recording tomorrow so you can go back and review it. And we'll see everybody next time. Regina, do you want to say any last closing words? Or?
No, I don't think so, but thank you everyone for attending.
Okay.
Thanks, Laura.
Thanks, Regina.